Hi, my name is Sophia Mokhtari, and my project here is on hydrogen fuel cells, a new source of power. Especially in this day and age, there is a growing concern for air pollution, predominantly vehicle emissions. Hydrogen fuel cells are the new sustainable power source of the 21st century, boasting zero pollutant and highly efficient motors. Fuel cells utilize up to 60% of the fuel's energy, consuming less than half the fuel consumption in comparison to an internal combustion engine vehicle. These fuel cells are over twice as efficient as combustion engines from the simple conversion of hydrogen's chemical energy into electricity. The most intriguing part of this innovation is that the byproducts of this reaction include pure water and heat, producing zero harmful pollutants. I have always taken interest in electric vehicles, and I have desired a green energy source, so why not utilize the most abundant element in the universe? Hydrogen. Essentially, this energy is coming from a redox reaction where these electrochemical cells produce a current. A fuel cell consists of two electrode ends surrounding an electrolyte. The negative electrode, known as the anode, is where fuel such as hydrogen gas is fed through. This anode is coated with platinum to act as a catalyst to split the hydrogen into its electrons and protons. This creates an electric current as the electrons can flow through the circuit and provide power to any load that is connected to the circuit. In this experiment, the purpose was to test the efficacy of using different electrolyte solutions in a Grove model hydrogen fuel cell to generate movement from an electric toy car. The effectiveness of the solutions was to be measured by comparing the car's distance and velocity, using the electrical current produced by the fuel cell to power the motor. However, due to many limitations, the fuel cell did not produce enough voltage to power the load in my experiment, the motor, so the electric car could not move. Since I was unable to power the electric car as planned, I was unable to analyze the movement generated by the different solutions I was testing. But I did find ways to compare potassium hydroxide, phosphoric acid, and sodium bicarbonate that I was using. I constructed my own fuel cell using a mason jar and two small glass bottles with platinum wires on the inside to act as the electrodes and a few different chemical solutions. I began by submerging the glass bottles in the mason jar and each solution at room temperature was used, and I connected the wires to a battery so the platinum could split the solution into electrons and protons. I would then take my observations of each chamber filling up with gas, and I decided I would run some more trials at different temperatures. I was taking note of the speed that the gas bubbles were being produced, their sizes, as well as the duration of time it took to saturate the chamber in gas. I then determined the average voltage per solution with potassium hydroxide producing an average of 1.1 volts, phosphoric acid producing 0.3 volts, and sodium bicarbonate producing an average of 0.07 volts. I also discovered a trend where the average time to produce the gas correlated with the voltage produced. Potassium hydroxide had the greatest average volume as well as the lowest average time, with an average of 1.1 volts being produced in around 9 minutes. All of my calculations concluded potassium hydroxide to be the most effective electrolyte, and these findings could be supported by the observations as well. Another discovery that I made was that the average voltage of each temperature across all the solutions increased as the temperature actually dropped. Overall, the findings of this experiment have proved potassium hydroxide to be the most effective electrolyte. I got the original idea of hydrogen fuel cells from my friend Jordan Van Hunnick, an engineering student at Western University. I discussed with him what an innovative and creative but also applicable topic would be that I could take to BASF that would lead me in the engineering direction. This helped me guide my research, and I was also able to formulate a procedure and a plan. However, planning does not always run smoothly, and there were numerous difficulties I ran into. The greatest roadblock that I hit was the limited access to the proper materials. For this experiment to be successful, the main component was the platinum wire. Unfortunately, due to the scarcity and the cost of this material, only 6 inches of wire could be acquired. This was detrimental to the experiment, as if more was available, more surface area could have been in each glass chamber, and there could have been numerous fuel cell glass chambers in each solution. Another difficulty was the inability to scale up in concentrations of solutions used. To keep the experiment safe to conduct in a high school classroom, the concentrations of the solutions were kept low. The potassium hydroxide solution used was a 1.0 molar solution, and the phosphoric acid was diluted to a 20% solution. Though this was not ideal, lab safety is far more important, and the procedure was designed to ensure safety while working with these corrosive, flammable, and hazardous solutions. These difficulties hindered my ability to produce enough voltage to achieve the objective of my project, to power the electrical car. I was able to overcome these difficulties by coming up with a new plan of action, different ways to manipulate my procedure and variables to still have a comparison to make between the solutions. I was not intending on testing 3 different temperatures, but I thought that could yield some interesting results, and if I couldn't achieve enough voltage, it would be interesting to see how to test different things to increase or decrease that voltage. What I enjoyed the most about my project was honestly just bringing it to life. I think my favorite part was hooking the wires up to the battery for the first time and watching the bubbles fizz off the platinum wire. I just felt so accomplished and proud knowing that I created that. I also enjoyed the fact that I was still able to achieve results and develop problem-solving skills and innovative thinking even when I ran into difficulties. Though I could not achieve the objective of the project, I would say that I did anything but fail. I discovered new trends and developed a theory to optimize the voltage produced in future projects. I would like to highlight my chemistry teacher, Mr. Breams, for the support and insight throughout the journey. During the difficulties, Mr. Breams would do his own independent research to be able to guide my project back to success. Mr. Breams always shifted the focus onto what went successfully and how to modify the experiment to test or manipulate new things, such as differing temperatures. With all this support, I feel motivated and even inspired to continue this project. If I was to further this research, I think it's worth looking into different materials to act as a catalyst. Platinum is very expensive and difficult to get a hold of, so to produce larger amounts of voltage, larger amounts of platinum will be needed. Precious metals are often used as catalysts, so it would be worth looking into testing gold, palladium, rhodium, and silver as well. If more materials prove to have the same catalytic properties as platinum, hydrogen fuel cells will become more popular and more affordable as an energy source. As well as this, it would be insightful to look into the nature of the electrolyte solutions and study if they denature as enzymes do with heat. It was interesting how potassium hydroxide with increased heat had become extremely unsuccessful. It would be worth looking into the properties of these chemical solutions and how temperature changes impact them on a molecular level. To further this experiment in the future, it would be worth testing cobalt wires as a catalyst instead of precious metals as a further advancement of the discovery I discussed in the introduction section of my report. Cobalt will be much easier to access as well as affordable, and a greater amount of it could be used in the experiment. Lastly, if this experiment were to be completed again, it would be interesting to focus on natural or homemade electrolyte solutions. If baking soda was able to produce voltage, could organic materials such as forms of greenery also produce voltage? Thank you for listening to my presentation, and I'm so excited that I was able to share my hydrogen fuel cell project with you.